Okay, and welcome to this video looking at simultaneous equations, particularly with focus on quadratics. In the previous video we looked at linear equations, and we're moving towards quadratics. So, we already know the basics of simultaneous equations by elimination or substitution, and we're going to use the skills from the previous page here as well. Before we get into doing some actual maths, let's just go through some concepts linking simultaneous equations to the previous topic which we've learnt in quadratics, called a discriminant. So we know that the point of intersection between a line and a quadratic curve can be found by solving simultaneous equations. The method of substitution is used from linear into the quadratic equation. So when we do simultaneous equations dealing with a quadratic and a linear, we like to use substitution because they're different types of equations. We can't just eliminate variables when you've got quadratic and linear. However, there may be 0, 1 or 2 points of intersection. So you could have a line intersecting quadratic once, twice or not at all. And if there's 1 point of intersection, the line is a tangent to the curve. Now, these three cases, 0, 1, 2 points of intersection, that there should be some sort of similarity between that and the discriminant in the quadratic section, and in fact there is. We can actually apply the discriminant on in this sort of workings with simultaneous equations and quadratics to prove what kind of geometric relationship there are between the line and the quadratic. But we don't just use a discriminant on the linear equation or quadratic equation, we use it at a specific point in the working where we have a quadratic in x. Okay, so if we have two real roots, the discriminant of that quadratic in x, not the original quadratic given to you, is greater than 0. If you've got equal roots, then the discriminant is equal to 0, and if you've got no real roots, discriminant is less than 0, and the line will not intersect with the curve at all. So I've got these two equations here. It's question 1. Just going to boil this down a little bit. Question 1. So we've got this question: solve the simultaneous equations y minus x equals 1 and 2x squared minus 11y equals minus 16 by a substitution. So they're already telling you which method to use. So y minus x equals 1 and 2x squared minus 11y equals minus 16. Now it's quite clear from here that we cannot eliminate variables because we've got 2x squared and we've got minus 11y. I mean, it just won't work. Okay, you can't subtract x terms in this way, and you can't cancel them out either. So we're going to have to use substitution. And again, when we do substitution, we want to try and find something which you can easily rearrange. So if I look at equation 1, I can rearrange that to make y the subject by adding the x onto the other side. Okay, and I'm going to call that equation 3. Now, once I've done that, I can then substitute that into the second equation. And when you do that, you've got to make sure you sub 1 plus x wherever you see y. So I've got 2x squared minus 11 times 1 plus x equals minus 16. Okay? You've got to be very careful with your manipulation of algebra here. Minus 11 minus 11x equals minus 16. Okay, and let's just tidy this up so that we can get a quadratic in x. So I'm going to keep the 2x squared here. Okay, I'm going to keep the minus 11x here as well, and this minus 16 I'm going to take down to the left hand side to make it a plus, so you get plus 5, and that makes it 0 here. Right, so we've got a quadratic. Now what I can do, I can factorise. I could either use quadratic formula or completing the square. I think this can be factorised, So let's go ahead and try and do that. Now I've got 2x squared to make when I factorise it, so I've got to make sure I've got 2x and x. I've also got to consider two numbers that when they multiply give me 5, but when they multiply with the x terms that I can also make minus 11. Now obviously if you sort of think about it, the factors of 5 are just 1 and 5, and we've got to make minus 11. So to make minus 11 I probably need a 10 from somewhere. So, and it's got to be a minus 10, so I'm going to make minus 5 here. So the 2x will go multiply with that to make minus 10, and I'm going to make a minus 1 here, so that minus x and the minus 10x gives you the minus 11x. Minus 1 times minus 5 is plus 5. So when you solve that, you get x equals 5 as one solution, and x equals a half. But remember, we also want the y values, okay? And what we can do is substitute those x values separately into this one or this, either one. So I'm just going to substitute into this. If my x value is 5, then the y value for that will be 6. If the x value is a half, the y value for that will be 3 over 2. Okay, so I can write that as a coordinate, or I can just write it in that form. Okay, so that is the solution for that simultaneous equation. Now that tells me that this line y minus x equals 1 intersects the quadratic, intersects the curve at two different points. It intersects at x equals 5 and x equals a half. Sorry, intersects in these coordinates 5, 6 and half 3 over 2. But let's say the question wasn't asking you to find the solutions, but to prove that it intersects at two different points. Well, we can try and use the knowledge from the notes where we look at discriminant. And where do we apply discriminant to? Well, we wouldn't apply discriminant here because that's a linear equation. We wouldn't apply it here because it's not an x term, it's a y term. And we'd have to apply it somewhere where there's just a quadratic in x. And this is it. So I'm going to apply the discriminant quickly on this line here. So remember, what is a, b and c? A is 2, b is minus 11, and c equals 5. Okay, so discriminant is equal to minus 11 squared minus 4 times 2 times 5. 121 minus 40, which is equal to 81. Now that discriminant is greater than value. The value of the discriminant is greater than 0. Therefore, this proves that the geometrical relationship between this line and this quadratic will be such that it's got two real roots. It will intersect twice, which the mathematics has proved. Okay. Right. Question 2. You've got another curve with a different equation, and you've got another line equation, and they're asking you to find points of intersection, so they want coordinates. Okay. So again, so I've got these two equations here. Now I don't need to do any rearranging here. They're both equal to y, and if they're both equal to y, then what we can do is make them equal to each other. Or another way of speaking, if that is equal to y, 2x plus 3, I can substitute that in for there. Now once I've done that, I can make a quadratic in x by making one side equal to 0. So I'm going to take all of this onto the right hand side. So I get x squared plus 2x, 4x minus 2x, and the 3 goes over, subtracts from the minus 12 to give me that. Okay. Now I'm going to solve this very quickly. X plus 5, x minus 3. Therefore x is equal to 3 and x is equal to 5. Okay. And when x is equal to 3, I can substitute that into there. When x is equal to 3, then y is equal to 9, and when x is equal to 5, y is equal to 13. So the two coordinates are 3, 9 and 5, 13. Okay. Now again, that tells me that the line 2x plus 3 intersects the quadratic at two distinct points. If I apply the discriminant, does that match up with the mathematics? So a is 1, b is 2, c is minus 15. Okay, so b squared minus 4ac, that equals 2 squared minus 4 times 1 times by minus 15, 4 minus 4 times minus 15 is plus 60, which equals 64, greater than 0, therefore 2 real roots, which the mathematics shows us to be true. Okay, so remember, we're applying the discriminant to see what the geometrical relationship is, but we're applying it at a specific stage in the working where we have a quadratic in x, which comes from doing the substitution from the linear into the quadratic. Okay, if you felt like you struggled with certain aspects of that, the practice questions are outlined here, and if you felt like that was fairly okay and you understood all the concepts really easily, then you've got the stretch and challenge questions here. That's the end of the video.